static member class. Note. A class that is defined as a static member of another class is called as static member class. A class that is defined as a static member of another class is called as static member class. A class that is defined as a static member of another class is called as static member class. See, just if you write static keyword, that is called static member class. See, I'll remove this. Here, I'll write static. Now, it is static member class. But this method is non-static. Okay, this method is non-static. For calling this one, B object required. For creating B object, A object not required. B class is a static member, but show method is non-static. Okay. Now, how to call? Here, P object you have to create. A object not required. Okay. Then you have to do like this. New A dot P. Then B dot show. Here demo class loaded, main method called. Here which object created? B object created with A class name because it is class member static with class name. Then you can call show. File, save. Compilation, execution. Alright, this one. Example 1. Example 1. For calling show method, B object required. For creating B object, A object not required. Is it over? New A dot B. New A dot B. Because B is a static class. That's what class name dot. Suppose this is also static. Think yourself and give me answer how to call this method. A dot, B dot, show. That's it. Say A dot, B dot, show. That's it. Okay. Ready, son? Example 2. A dot, B dot, show. So A dot, B dot, show. A dot, B dot, show. Okay. For calling show method, class name B. For calling B, A. A dot, B dot, show. Is it over? Now, it is static, class name. It is static, class name. Next, third one, local class. What is local variable? Inside a method. Same style here also. A class that is defined inside a method. A class that is defined inside a method is called as local class. A class that is defined inside a method is called as local class. A class that is defined inside a method is called as local class. Is it over? See. Here you observe. Okay, directly I'll write here. It is also method only, no? It is also method. Here only I'll write class test void show system dot out dot println welcome. Local variable scope is limited to method only. Local class within the method only can access. Here only you have to create object. Here only you have to call. Ready, son? Is it over? Inside a method, we created a class. That class is called local class. These three classes, not much important, but anonymous class, most important. Okay. Now, fourth one. Note, anonymous class. Anonymous class. This class is most important. See, it is a one type of inner class. It is a one type of inner class which has no name. It is a one type of inner class which has no name. It is a one type of inner class which has no name. It is a one type of inner class which has no name. Without name class created. Okay. It is always subclass of a class or interface. It is always subclass of a class or interface. It is always subclass of a class or interface. So if you want to create anonymous class, that class compulsory subclass only. Subclass of a class or interface. So anonymous class as a superclass not possible. Anonymous class as a outer class not possible. Anonymous class compulsory inner class. Anonymous class always subclass. See, listen with more concentration. It is little hard to understand, but it is only most important. Java 8 features, 11 features I given, almost 7-8 features based on this program only. Okay. Listen with more concentration. Suppose one interface, just yesterday or day before yesterday you studied. Okay. Now, what is the interface? Interface definition. What is the interface? Collection of public, static, final variables and public abstract methods studied. Okay. Now, here, void show. Is it abstract method or concrete method? Is it abstract method or concrete method? Abstract method. Is it valid or invalid? Valid, but abstract keyword record implicitly present. That's what valid. Okay. Now, this line, is it valid or not valid? This line valid or not valid? Why it is not valid? Interfaces cannot be instantiated. If you create object, error. You can create object reference, but you cannot create object. Okay. Here, test is an interface. Test is an interface. You cannot create object to interface. This line is error. Test t equal to new test is error. Okay. You cannot create object. Now, you observe file save. If I compile, we'll get an error. Test is abstract. Cannot be instantiated. Test is abstract. Cannot be instantiated. But where is abstract? Implicitly abstract. So if I write abstract, any effect will be there? No. If I write here also abstract, any effect will be there? Whether you write or not, abstract will be there. Okay. Here and here, abstract will be there. Now, error coming. But what I'll do, you observe, I'll write like this. If I write like this, it is valid. If you write like this, what will happen is, it is a little bit complicated syntax. Listen with concentration. If you write like this, it is valid. Then what will be happen is, one class created. Is there any class keyword? No. Is there any class name? No. That is only anonymous class. Okay. If you write like this, one class created. There is no class keyword. There is no class name. That class implements test interface. Implements keyword also not there. You observe. So if you write like this, one class created, that class name not there, that class implements test interface. This interface inherited in this class. Already you studied. Whenever interface is inherited, then what we have to do? Whenever interface is inherited, then what we have to do? All abstract methods must be overridden, or subclass must be declared with abstract keyword. Otherwise, compile time error occurs. That error occurs, but this error will not occur. Now it is valid, but error is overriding error occurs. See here, anonymous class, anonymous, that is demo $1. Here, anonymous class is a member of demo class, local class, is not abstract and does not override abstract method show in test. What system saying? This is not declared as abstract, not overridden. Either override or write abstract. Now I'll override. Is it valid overriding or invalid overriding? Is it valid overriding or invalid overriding? Valid or invalid? How many plans are valid? 1, 2, 3. Only 3, 4, 5, 6, 7. Online students. How many plans are not valid? Why it is not valid? You studied access modifier rule. Here, what is the access modifier present? Public. Not no name here. It is interface. In interface, implicitly, public. Here, public is there. Here, what is there? No name. Access modifier rule is there, no? Here, public is there. Here, what is the record? Public only record. That's what, not valid. See, file, save. That access modifier error. See, show in anonymous cannot implement show in test. Attempting to assign weaker access privileges was public. Okay. So it should be public. Now it is valid. Now, here actually what will happen is, if you write like this, one class created, there is no class keyword, there is no class name. That class implements test interface. Implements keyword also not there. That class object created, that object referred by T. With that T, you can call method. This is anonymous class. See, file, save. I'll compile. I'll execute. In this program, how many interfaces are there? How many? One. What is the name? Test. How many classes are there? How many classes? Two classes. What are those? Demo class, anonymous class. Demo class, anonymous class. If I compile this program, how many dot class file generated? How many? 3. Test dot class, demo dot class, demo $1. Dollar indicates inner class. Dollar indicates inner class. Name not there, but here one comes. That is file generating file, one comes. Now I'll explain example 1. Write this one. Example 1. Write this one. I'll explain with example coding. I'll explain. Just write example 1. I'll explain. Listen. You observe. I written like this. If you write like this, what will be happen? See, one class created without class name. That class implements test. One class created, there is no class keyword. There is no class name. That class implements test interface. Implements keyword also not there. Public void show. System.out.println. Welcome. Now, here, which is super interface? Which is super? Here, inheritance is there or not? Yes. Which is super interface? Test. Which is subclass? Anonymous class. Now test T equal to new anonymous class. This line valid or not valid? Valid or not valid? Which object created? Anonymous class object created. Test reference created. T dot show. So if you write like this, you assume like this. For understanding purpose, internally how it is there, what they written, not given to us. Like this, understanding purpose I given. If you write like this, one class created with that class is called anonymous class. That class implements test interface. This class object created, that object assigned to test with that show method called. What a point? Here, this class object created, anonymous class object created. This class is called anonymous class. It is a little complicated. All right, this one. Understanding purpose, that is. Like if I write like that, assume like this. Okay. If you write like this, one class created without class keyword, class name also not there. That class implements test interface, method overridden. That class object created, that object referred by T with the T show method called. It is subclass object super interface reference. Upcasting. Subclass object super interface. Upcasting. Upcasting always valid, no? Like that show method called. Now, what I'll do, see here. Little bit I'll change. Here, with object reference called or object called? With object reference. Now, with object, if you want to call, test T, no need to write. Here. Dot show. Now, anonymous object. Anonymous class, anonymous object. Later you will see this program, total program, one line we can write. That is lambda expression. Later. 10-20 lines code, just in one line we can write. 10-20 lines. New concept. Java 8 features. That is further I'll teach. Present not possible. Later I'll teach. 10-20 lines code, just in one line we can write. one line. That is the anonymous method also possible. It is anonymous class, anonymous object. Later anonymous method. That is only lambda. Okay. Now file save. Previous program anonymous class was there, but in this program anonymous object also. Okay. Write this one. Example 2. Example 2. Oh, is it over? In this program, how many classes are there? How many classes? 2 classes. What are those? Demo class, anonymous class. How many interfaces are there? 1. That is test. Now, test is an interface inherited in anonymous class. Test is an interface inherited in anonymous class. So it is anonymous class. It is super interface. It is interface. It is class, normal class. Now, it is a subclass of test interface, and it is an inner class of demo class. Write this one. It is a subclass of test interface, and it is an inner class of demo class. It is a subclass of test interface, and it is an inner class of demo class. It is a subclass of test interface and it is an inner class of demo class. Say, this is nameless class. That is only anonymous class. It is a subclass of test interface. It is inner class of demo class. Inside the demo class I created. That's what inner class of demo. It is subclass of test interface. Okay. If I compile this program, how many dot class file generated? 3. Is it over? Now see, file save. Here, first in my system, all dot class files I'll show you. So many dot class files are there. See, these many dot class files are there. I'll delete all. Delete star dot class. All dot class file deleted. Now I'll compile. Now I'll check it. See how many dot class files are there? dir. No dot class files. File not found. Okay. Now I'll compile my program. Javac demo.java. Now display dot class files. See 3. Demo.class, test.class, demo$1 class. It is anonymous class. It is inner class of demo. This dollar indicates inner class. Okay. Now you write like this. If you compile javac demo.java, here demo.class, test.class, demo$1 class. Here dollar indicates inner class. Here dollar symbol indicates inner class. It is anonymous class dot class file. It is anonymous class dot class file. So 3 dot class file generated. Demo.class, test.class, demo$1 class. Here dollar symbol indicates inner class. Is it over? Now here anonymous class I created. Anonymous class is a member class or static member class or local class. Which class? In this example, it is local class. If you create outside, member class. If you add static, that's it. Write that point. In the above example, anonymous class is a local class. In the above example, anonymous class is a local class. In the above example, anonymous class is a local class. Is it over? Now, class A, static class B, class C. Now, here, this is which class? Which class? Member class. It is static member class. It is a local class. Okay. Now, this class is called outer class. This class is called outer class. These classes are called inner classes. But for this one more name is there. Actually, this is outer class also you can call. Top level class also you can call. Top level class. This class, another name, nested top level class. Because it doesn't record object. That is the reason we'll call like that. These three are called inner classes. All right, this one. So outer class, top level class, both are same. Static member class, nested top level class, both are same. So outer class or top level class, both are same. Member class, static member class, nested top level class, both are same. By using static keyword, we can create nested top level class at the time I given. That is. Is it completed? Now, note outer class cannot be private and cannot be protected. Outer class cannot be static. For outer class, if you write private, error. Outer class, if you write protected, error. Outer class, if you write static, error. Outer class cannot be private and cannot be protected. Outer class cannot be static. Member class and static member class can have all access modifiers. Member class and static member class can have all access modifiers. Member class and static member class can have all access modifiers. Local class access modifiers cannot be applied to local class. Access modifiers cannot be applied to local class. Say, instance variable, private, protected, public, default, you can write. Class variable, you can write. For local variable, can you write? No. Local variable scope is limited to method only. Again, access modifier, you cannot write. That's what here also not possible. Access modifiers cannot be applied to local class. And local class cannot be static. Local class cannot be static. Now, just now in the diagram I given, which are local classes, which are member class. Based on that, you can understand. See, outer class cannot be private and cannot be protected. In that example diagram, which is outer class? For demo class, you cannot write private, you cannot write protected. Error comes. You cannot write static also. Member class, static member class can have all access modifiers. Which are member class, static member class? A and B class. For A and B, all access modifier applicable. Access modifiers cannot be applied to local class. Which is local class? C. For C, you cannot apply access modifier. Local class cannot be static. Okay, you cannot write. C. Integer x equal to 10. Here, which access modifier present? Which access modifier present? No name. It is default in a class. Okay. Here, which access modifier present? No name. Default. Here, which access modifier present? Which one? Public. Okay. Here, public. Public is default. Here, no name is default. Here, no name is default. Here, which access modifier present? Access modifier is not present. Default also not there. No name also not there. Access modifiers not applicable. Okay. So you cannot, here no name also not there. Here no name is there. Here no name. But here no name also not there. Access modifier is not there. Like that. Not applicable. This variable scope is this variable scope is this variable scope. No limit. There is no restriction. Public, no, that is public scope is not restricted. So this variable scope is not restricted. Anywhere you can access. This variable scope is within the package. This variable scope within the method. For that, access modifier concept is not there. Okay? Clear? Here, which access modifier present? Public. Here, which access modifier present? No name. Here, no access modifier. No name also not there. Okay? Access modifier is not applicable. Like that only here. Outer class cannot be private, cannot be protected. Outer class cannot be static. Here, local class cannot, access modifier cannot be applied to local class. Local variable we cannot apply. Local class we cannot apply. Clear? This is about inner classes. In inner classes, only this is important. Okay? This is further sessions required. With this concept only, one new concept introduced, functional programming. Function can be passed as a parameter to another function with lambda expressions. That is only new concept. What is the benefit is we can concise the code. 10, 20 lines code, just in one line we can write. 10, 20 lines code in a one line. That benefit is there. Further I'll explain that one. Next topic, next concept, packages. Note. Next one, packages. A package is a collection of subpackages, classes, and interfaces. A package is a collection of subpackages, classes, and interfaces. A package is a collection of subpackages, classes, and interfaces. See, in a one program, 10 classes are there. 10 classes. If I compile, how many dot class file generated? 10 dot class file generated. If interfaces are there, for that one also dot class generated. For inner class are there, inner class also dot class generated. Okay. Depends upon number of classes, number of interfaces, number of inner interfaces, number of inner classes. These all dot class file generated. One class equivalent to one file. Got it? One class equivalent to one file. One interface equivalent to one file. One inner class equivalent to one file. One inner interface also we can create. That is also one file. Package nothing but folder. So here suppose here this PC, 2 drives are there. In each drive, these are folders. In each folder, some files. Like that we have. Okay. Here folders are there. In a folder, again folders are there. Again folders are there. Files are there. Like that we have. Just assume folders are not there. Assume no folders. Very difficult to manage file system. No? Very difficult to manage file system. Because of folders, you are managing files in a proper way. Just assume there is a one hard disk. that hard disk, only one drive is there. In that drive, no folders, only files are there. Very difficult to manage, no? So how you are managing your files, your hard disk, you are dividing into 4 drives: C drive, D drive, E drive, F drive. One drive, what will do? All softwares will install. C drive. One more drive, D drive. All software dumps, whatever you downloaded from internet, dumps will place in one folder, drive. E drive. What are the programs you are writing daily? Those all programs in one drive. Like that you are organizing, no? One more drive, F drive, all entertainment files. Okay. Your photos, videos, audios, images, graphic, these all one more folder drive. Like that you are managing, no, in laptop. So your hard disk, you are dividing into number of drives. One drive for software installation, one drive for software dumps, one drive for your programs, one drive for entertainment files. Like that you are dividing. Suppose E drive. In the drive, again you are creating some folders. Java folder, HTML folder, Oracle folder, like different folders. In Java folder, again, fundamentals one folder, topic wise, object oriented programming folder, exception handling folder, multi-threading folder, collections folder, like that, topic wise folders. In that folder, you are going to maintain files. Like that, if you maintain, in future, searching becomes easy. Updating becomes easy. Okay. Suppose you want to update, you want to search for one multi-threading program. Directly will come to E drive, Java folder. In that core Java folder, in that multi-threading folder, even multi-threading programs. So like that, easily you can manage, easily you can update, easily you can search. That's what you are doing. You are maintaining files in a folders. Like that only, while developing projects. Projects means only one program? No. Hundreds of programs will be there. Then what we'll do, which are related to one particular module, those all in one package. Suppose you are developing one website. In that website, 5 modules are there. Mail module, chart module, games module, sports module, news module. Suppose 5. Mail related programs in mail package. Chart related programs in chart package. Games related programs in games package. Like that you can manage. That purpose this concept required. See, Java library organized in the form of packages. Starting session I given. Java library organized in the form of packages. Library, if you open, you'll get a package, Java A package, org package, launcher package, sun package. Many packages are there. Package, if you open, again sub package, sub modules, language related, lang package, collections related, util package, AWT related, AWT package, applet related, applet package, input output related, IO package, net related, net package. Like that, maintaining. Then what will happen if you want to develop internet application, network program, net package will open. You want to write program language related, lang package. Like that organized. Same style, while developing projects, you create according to your requirement number of packages. In each package, sub package, again sub package, classes, interface, variable, method, all you can maintain. Then in future, if you want to update the project, if you want to maintain the project, very easily maintain, very easily you can update. That purpose this concept required. Next, write it. The Java compiler generates dot class file for every class and every interface in a source file. The Java compiler also generates folder for every package and every sub package in a source file. The Java compiler also generates folder for every package and every sub package in a source file. .java file. The Java compiler generates .class file for every class and every interface in a source file. .java file. The Java compiler also generates folder for every package and every sub package in a source file. .java file. So for every class, .class generated. Every package, one folder generated. Every package, one folder. Every sub package, one folder. So folder automatically generated by compiler. .class file automatically generated by compiler. So one class equivalent to one package equivalent to one folder. All packages are folders, but all folders are not packages. Okay. All packages are folders, but all folders are not packages. Which is generated by Java compiler, that is you can call also. But whichever you created, that is not called package. That is only folder. Okay. Because right click new folder. That is not a package. Whichever Java compiler generate, that is package. Like that. Okay. Now, with this knowledge, what will happen? Your Java program can be anywhere. Your class file can be anywhere. You can access from anywhere. That is, you will understand. Previously, all what you have seen, Java C, demo.java, Java demo. Like that you have seen. Now, anywhere you can place. See, for example, C drive. Suppose in a one drive, generally what we'll do while dividing projects, we'll divide we will create two folders. One is SRC folder. One more classes folder. While creating packages, while developing applications, SRC folder, classes folder, two separate will create. All .java files here, all .class files here. Class files, .java files will make it separate. Reason, while developing web application, your .class files you have to copy in server. Then if you make it separate, only .class you can deploy. .java also if you deploy, other people can see your code. Then what they'll do? They'll copy your website. They'll change them address, mail ID, logo, all those things. They'll make it their own website. Okay. .class files only you have to copy. While developing only, you have to make it separate. These are automatically done by Eclipse, MyEclipse, NetBeans. These are all IDEs. Further I'll teach. Okay. SRC folder, classes folder. In a classes folder, you create separate. Depends upon number of packages, create packages. Suppose here, pack 1, one package. Pack 2, another package. Now, pack 1 package, pack 2 package. Like what you have to do, suppose mail package, chart package, games package, sports package, news package, movies package, shopping package, like that. Depends upon application names, you can write. In that package, if any sub modules are there, sub package you can create. Not there, classes also. Suppose one A dot class. Here, one sub package. Pack one sub package. Year one class I'll write. B class. Year one class I'll write. C class. Suppose in my project, 5 modules are there. 5 packages. In that sub modules are there. Suppose 3 sub modules are there. 3 sub packages. In each package, each sub package, some classes interfaces will write. All dot class files here. A dot Java, B dot Java, all dot Java files here. One more main dot Java. It is separate. In the entire website, where you want to execute, home page, we'll make it separate. That is one more package separate outside. Suppose here test package. Here main class. Now what I will do say, these all I'm going to access in this class. Like that you are going to learn. A class, B class, C class, I'll access here. If you want to access here, this package you have to import. This class object you have to create. Then you can access. This class of this package you have to import. This object you have to create. Then you have to call method. This package you have to import. This class you have to create object. You have to call. Like that you are going to see. Note on this one. Like this, I'm going to give example. here package are given. No, those all automatically generated by Java compiler. Dot class are given. No, those all automatically generated. Remaining we have tried. So this C drive already present in our system. We have to create src folder, classes folder. We have tried these 4 and these all automatically generated. Whenever you compile a.java, this is generated, this is generated. Whenever you compile b.java, this is generated, this is generated. Whenever you compile c.java, this is generated, this is generated. Whenever you compile main.java, this is generated, this is generated. So package folders automatically generated by Java compiler. Dot class files generated by Java compiler. Okay. This program we'll see tomorrow.